Everybody, and welcome to this video which provides an introduction to system of inequalities. And so here is exactly what a system of inequalities is. A system of inequalities is going to be, and we're talking about two variables, which means we're going to use the variables x and y when graphing with these, consist of at least two linear inequalities in the same variables. So what a system basically is going to be a group of inequalities. And that group, what we're going to look at is what possible solutions are provided to that group. A solution of a system is going to be when I have a group of ordered pairs that are going to be solutions to all of the inequalities in that system. So if I have 5 different inequalities listed, 1, 2, 3, 4, 5, and I have all of them listed out here, a solution of a system means that that particular ordered pair must be true for all 5 of those inequalities. Now, for this lesson, we're mainly only going to focus on 2, and we're going to see how that ends up working. This group of ordered pairs, however, creates a shaded area, which is called a solution area. Now, we're fairly familiar with solution area as we've looked at solving, I guess we'll call them systems of linear inequalities, but only with one equation. And so that one solution area is very similar to what we're going to be doing here with a system of 2 or more inequalities. So what we're going to do is go back and look at one particular question that we focused on in a previous class, and that is listing two numbers whose sum is less than or equal to 10. And what you guys did in this particular warm-up is you wrote a list of all ordered pairs in which when you add their sum up, it ends up being less than or equal to 10. And you see this drawing down below. Now note there are a few here that are incorrect, so I'm going to through them. Those are all incorrect answers, but everything else on this grid is correct. And what you'll notice is here I have, first off, I see something that looks like a line, and we'll talk about that in a second. Okay? But I have this entire group down here. Okay? All of these ordered pairs that are dotted together. This is what we call our solution area. And this solution area lists all the possibilities. And so even though you have a few dots here that represent specific answers you guys found, I know that an answer right here, which is a decimal answer, or an answer here, or a negative answer, or a negative answer, all of these spots that I'm drawing here are additional solutions that I can tell. And when we graph linear inequalities, what we typically like to do is instead of looking at it from individual dots, is we look at this line, which is essentially your boundary line. That boundary line, guys, is this equation right here, or this inequality, I should say. When I have two numbers whose sum is less than or equal to 10, well, x is number 1, y is number 2, and it has to be less than or equal to 10. Now, when we graph these, we typically like to put it in slope-intercept form, which basically means we want to get y to be by itself. And so when I do that, I get y is less than or equal to negative x plus 10. What that means is that my y-intercept is going to be 10, and my negative 1, because that's the number that's in front of the x, is going to end up being my slope. And so when I graph this inequality, this is what I end up with. There's my y-intercept of 10. My slope of 1 means I'm going to go down 1 and over 1, and that's where my line comes from. Remembering that less than or equal to means I'm going to include the boundary line, so it's a solid line. And since we're going less than, we're shading everything below that particular boundary line. So this creates that solution area that we've been talking about. Now I'd like to take a look at this question here. I want you to list two numbers whose sum is greater than positive 3. And I want you also to write these as an ordered pair. So take a moment to pause this video and write 2 or 3 solutions down for me, and then we'll talk a little bit about it. And now that you've taken a look at that, here are a few solutions that I can think of as looking at it. So for example, the number 1 and 4. That's a possible solution because 1 plus 4 is 5. And 5 is greater than 3. I could throw negative 2 and 10, positive 10. Negative 2 and positive 10 give me 8. That's also greater than 3. One you do need to be careful with, for example, if you write 1 comma 2 down, that is not a solution because that adds up to 3, and 3 is not greater than 3. I want to be more efficient than writing ordered pairs, I would much rather write myself an equation for this, or I should say an inequality, since there'll be an inequality sign instead of an equal sign. Take another moment to pause this video, and I'd like you to write down what the inequality would be for this, knowing that the two numbers that we're listing, we're going to call the first one x and the second one y. And now that you've taken a look at that, here's what I came up with. I came up with x plus y is greater than positive 3. And just like we've been doing before, when we want to graph this, we want to get it into slope-intercept form, which means I want to get y by itself. So I'm going to subtract x from both sides, giving me y is greater than negative x plus 3. And once I have that, now I know my y-intercept is going to be positive 3. My slope is going to end up being negative 1. And here's what that ends up looking like. So just to recap, there's my y-intercept of 3. My slope is negative 1, so I go down 1 and I go over 1. I create a dotted line. Since it's greater than, it does not include the boundary line. And once again, here is that solution area that should have what all the possible answers of numbers that add up to be greater than negative 3. Everything in this blue area is a possible solution. And this brings me now to the punchline. What is a system? Well, a system of inequalities is going to be when we combine two of these statements together. So asking this question, list two numbers whose sum is less than or equal to 10, and also whose sum is greater than 3. So we need a pair of numbers that are going to accomplish both things. That will be a solution to both the red and the blue graph. Take a moment to pause this video again and see if you can address and find maybe one solution that will fit this description. And so basically what you need to do is have a number that is, I guess, whole number wise, anywhere between 4 to 10. So as long as you have something in that range, you're going to be okay. So for example, I could do 2 and 3. 2 plus 3 is 5. 5 is less than or equal to 10, and 5 is also greater than 3. But let's take this from a graphical standpoint. So I have both our graphs here that we've been discussing throughout this video. Here's graph number 1, and here's graph number 2. I need to know where the solution areas, the red solution area and the blue solution area, end up overlapping. And with the power of this smartboard, I'm going to make this a little transparent. And what I'm going to do is I'm going to slide these two graphs on top of each other so that the numbers are matching each other. And what you should notice here is the blue area begins right here at this dotted boundary line and is everything above it. And the red shaded area is everything from this solid line below. And so the area in which they're going to overlap, and I will take my highlighter pen to show you, the overlapping area is everything in between here. This creates my solution area when we do a system of inequalities. So in short, a system of inequalities is going to be when both the shaded areas are overlapping each other. And so this, if I can find my pen, there it is. This yellow area is my solution area. Now I mentioned on the previous slide that I said 2, 3 was the solution. Just to confirm, here's 2, up 1, 2, 3. So that was the solution that I gave on the previous slide, and you can see that it is in the yellow area. To wrap up this video, I'd like you to pause this again and see if you can identify 2 additional solutions that will fall within this yellow solution area. And that will conclude this video. Be sure to take a look at the second part of this video, which talks about more specifics on how to graph systems of inequalities. Thanks for watching.